Okay, so this next video covers a concept called the rational root theorem. Now, the rational root theorem, there are only 2 questions in the textbook on this. It is technically in the study design, but I've never seen it assessed, and I honestly cannot imagine a time when they would bother to assess this. Essentially, this is still factorising cubics, or factorising degree 3 and higher polynomials. But it's thinking about the fact that when we use the factor theorem and the method I showed you in the end of the previous video, we're actually, it's not always going to work, and it only works all the time. It's only worked all the time so far because we give you a certain selection of questions to answer. Okay, if we ever think about this polynomial that I've got here, so 3x cubed minus x squared minus 15x plus 5. That factorises. It factorises to 3 fairly nice linear terms, 3x minus 1, x plus root 5, and x minus root 5. Now the problem is if I asked you, I didn't give you this factorised form and I asked you to factorise this, your first step would be to try and identify one factor using the factor theorem. Now the factor theorem, we generally test integer values. We substitute integers into the polynomial until we get something that gives us 0. Now in this instance, you're not going to get an integer that gives you 0 because none of these factors, this would be when x equals a third, this would be when x equals negative root 5, and this would be when x equals positive root 5. Now we're not suggesting that you should be starting to trial and error surds, because actually the surds mean there's potentially infinitely many possibilities to trial and error, and you'd be there forever. But what we want to think about is, okay, well, if we don't get if the factor theorem doesn't give us anything. So the other thing to think about when we're using the factor theorem to try and find our first factor, is there's not infinitely many things we can try. So what we're essentially trying to do is we're trying to factorise a polynomial. We know that, okay, there's a 3x cubed here, so that would mean there's probably a 3x and an x and an x. Possibly not, but let's just go with that for now. And then we would think about this plus 5, because what we're essentially doing is thinking about the 5, and we can only have 5 and 1 and 1, or negative. So the only factors that could possibly go in these brackets would be plus or minus 1, plus or minus 5. So they'd be the only integers we need to try. There's no point in trying, f of p of 7, because x minus 7 is not going to be a factor. 7 doesn't go into 5. That wouldn't give a plus 5 on the end of the polynomial. So once we've exhausted all the integer options, we've tried plus minus 1 and we've tried plus minus 5, and we know there's no integers that will make the polynomial equal to 0, we then want to start to think about, what about rational numbers, i.e. fractions? So what about, perhaps there isn't a factor of the form, x minus an integer. Okay, there's none of those. There's x minus a third, but not x minus an integer. But maybe there's a factor of the form ax plus b, or ax plus or minus b. Okay, so which would give a rational factor, or a rational solution. So we want to now start to think about that. Okay, so if we can't find an integer k such that p of k equals 0, so we've exhausted all the possibilities, we've tried plus minus 1 and we've tried plus minus 5 in this instance, the next thing we're going to do is assume that there must be a factor of that form, ax plus b. Now, it's possible there might not be, but yeah, so again, we're still not looking at all the possibilities, but this is our next step to ensure that we've done everything we can. So according to the factor theorem, if ax plus b is a factor, that would mean that negative b on a, when we substitute x equals negative b on a into the polynomial, we make the polynomial equal to 0. Okay, so logic tells us, if again we think about what's happening here, if these two things have to be equal, the a has to be a factor of 3. The only way you're going to have ax in the bracket is because it multiplies together with the x in another bracket and the x in another bracket, or the 2x in this bracket. It multiplies to give 3. So the a value has to go into 3, has to go into the coefficient of x cubed, and the constant term in this bracket b is going to have to go into this 5. Okay, again, that's just thinking about how you expand out brackets. So b must be a factor of 5 and a must be a factor of 3. Okay, so what that means is A could be positive or negative 1. Let me just show you how I got to here. A could be positive or negative 1, so a factor of 3, or positive or negative 3. Okay. B can be positive or negative 1, or positive and negative 5. So then if we're trying to think about, negative B on A, I'll just worry about B on A because everything, the negatives will come into all the possibilities anyway. So if I make fractions, if I think about B on A, so B on A, well, it's the same as negative B on A, could be positive 1 on 1. It could be, negative 1 on 1. If it's negative 1 on negative 1, that's the same as positive 1 on 1. Similarly, if it's 1 on negative 1, that's the same as positive 1 on, same as negative 1 on 1. So we don't need to worry too much about the negatives. And then B could be 5. Oh, sorry. So we could also have B as 1 over the 3. So we could have 1 over 3 or negative 1 over 3. Then we could have the numerator as 5. So we could have 5 over 1 or negative 5 over 1. Or we could have 5 over 3 or negative 5 over 3. Now, they're all the possibilities. A lot of those we've already checked because we assume we've already checked all the integer values. So that's 1, that's negative 1, they're integers, we've done that. That's 5 and that's negative 5, we've done that. So there's this pair of possibilities and this pair of possibilities to check. And then we just have to check them. Okay, so it can be a bit of fraction work, and there can potentially be quite a lot of fraction work if it's the last one we test that happens to be the correct one. So in this instance, if we try subbing positive a third into the polynomial, we find that that indeed gives us 0. So if p of 1/3 is equal to 0, that means that 3x minus 1, remember when you solve that equal to 0, it's got to give you a third. 3x minus 1 must be a factor. Then once you've got the factor, you can do the long division to define the other factors. Okay, let's just work through 2 examples. So we want to factorise this. So the first thing we're going to do is we're going to try and use the factor theorem. And we know it's going to have to be a number that goes into 3. Okay, so we would try p of 1. So that's going to be 4 plus 1 minus 12 minus 3. So that is 5, negative 7, negative 10, I think. So not 0. P of negative 1 is going to be negative 4 plus 1 plus 12 minus 3. So that is negative 7 plus 13, so that is 6, which isn't 0. P of 4 would be, sorry, not 4, P of 3. Again, has to be factors that go into 3. P of 3 would be 4 times 27 plus 9 minus 36 minus 3. I'm already seeing that 4 times 27 is going to be more than 100. So we've got more than 110, say for example more than 109, which is not counterbalanced by that negative 39. So without having to work it out, I know it's not 0. And P of negative 3, again I can use the work that I've done here, it's going to make that negative 27, so we're going to have 4 times negative 27, still going to be positive 9. It's going to be plus 36 and minus 3. Okay, so again, at this time, now we've got, we've got positive 45, which is not going to be balanced by negative 100 and, negative more than 100. Okay, so again, doesn't equal 0. Alright, so at this point, we don't give up. Okay, so there's not an integer factor, there's not a bracket of the form x minus k. Okay, so now we assume a factor of the form ax plus b. Now a is going to have to be a factor of 4, which is the coefficient of x cubed. So a can either be plus or minus 1, plus or minus 2, or plus or minus 4. And b has to be a factor of 3. So b can be plus or minus 1, or plus or minus 3. Okay, so in terms of thinking about b over a, or negative b over a, it could be plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4, or we could have plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 3 over 4. Now again, some of these we've checked because we've done the plus minus 3 and we've done the plus minus 1, so we can omit those. But it does mean we do still have 8 possibilities that we're going to need to check. So we really are just hoping that one of the first ones that we try works. Okay, so we try p of half. Now you don't have to start with a half, you can try whichever one you want, but half's going to be the nicest one to work with there. Okay, so let's put that into our function. So it is 4 times, so I'm going to try and do a bit of this in my head as I go so I don't have to write down so much. 4 times a half cubed, half cubed is 1/8, plus half squared, which is a quarter, minus 12 times half, which is 6, and minus 3. Okay, so that's going to be 4 times an 1/8 is a half, half plus a quarter minus 9. So certainly 3/4 take away 9 doesn't equal 0. Okay, let's try p of negative a half. Now again, you want to think about using, what you can use. So if here we subbed in positive a half, now we're going to sub in negative a half. What's going to change is this first term is going to become negative, because negative half cubed will be negative 1/8, and this term the sign of this term will change as well. But this won't change because negative half squared is the same as positive half squared, and this won't change. Okay, so it's just changing the sign of the first and third terms. So that's now going to be 4 times negative 1/8, still plus a quarter. It's going to be plus 6 and minus 3. So that's going to be negative half plus a quarter plus 6 minus 3. So again, negative half plus a quarter, that's negative a quarter plus 3, which doesn't equal 0. Okay, so p of a quarter. So that's going to be 4 times, now 1/4 cubed is 1/64. And then we've got plus 1/4 squared, which is 1/16. Sorry, 1/16. And then we've got minus 12 times a quarter, which is minus 3 and minus 3. Okay, so 4/64, that's 1/16 plus 1/16, and then minus 6. So we've got 2/16 take away 6, definitely not 0. P of negative a quarter. Again, the first term becomes negative, so it's going to be negative 1/16, and 4 times negative 1/64. The next one stays positive. The sign will change for the third term, so it's going to become plus 3 and minus 3. Okay, so that's nice. Negative a 16th plus a 16th, they cancel out, and 3 minus 3, they cancel out, so that's 0. Okay, so that tells us that if x equals negative a quarter makes the polynomial equal to 0, that's because 4x plus 1 is a factor. Okay, so now we can divide that in. So we're going to divide 4x plus 1 into our polynomial, which is 4x cubed plus x squared minus 12x minus 3, 4x cubed plus x squared minus 12x minus 3. Just check it was that. Yep. Okay. What do we multiply 4x by to get 4x cubed? Well, that would be x squared. Multiplying x squared by 4x plus 1 gives us 4x cubed plus x squared. Subtract. We actually get 0. I'm going to keep the 0x squared just so I can be clear about what terms I'm dealing with. Even if you get a 0, you still have to persist through the process. So bring down our next term. What do we multiply 4x by to get 0x squared? Well, that's going to be 0x, isn't it? Again, it feels a bit trivial, but we sort of just need to push on to get to the next stage so we can access this negative 3 here. So 0x multiplied by 4x plus 1, so that's 0x squared plus 0x. The x is obviously irrelevant, I'm just trying to maintain the place value in the columns. And we're subtracting negative 12x minus 0x is still negative 12x. Bring down the next term, which is minus 3. What do we have to multiply 4x by to get negative 12x? That would be negative 3. Multiply negative 3 by 4x plus 1, negative 12x minus 3. Good, remainder of 0, which is what we want. Okay, so therefore, where are we up to? So we now know that 4x cubed plus x squared minus 12x minus 3 is equal to 4x plus 1 times x squared minus 3. Now, the question says fully factorise, or I should say fully factorise, factorise. Now, we're actually done here. It is possible, you could write x minus 3 as x minus root 3, sorry, x squared minus 3 as x minus root 3 times x plus root 3. But the minute you have to factorise into surds, you're going a step further than you need to. Okay, so if it won't factorise any further without the need for surds, you can stop at that point. So 4x plus 1 times x squared minus 3. And that's why we couldn't find a factor using the factor theorem, because the three linear factors either involve surds, x minus root 3, x plus root 3, or a fraction, which is why we needed the rational, i.e. fraction, root theorem. Okay, there's one more example. If you feel you've got a grasp of that, by all means stop the video and move away. You can go on and do the practice from the exercise. It's 4D questions 16 and 17 are these. Otherwise you might want to pause the video, have a go at this one yourself, see how you go, and then watch through the description after that. Okay, so again we want to start. This time I'm just going to make life a bit easier. Let's assume, let's imagine that we check all the integer factors. Okay, so let's find that, you know, p of plus or minus 1 don't give us 0, p of plus or minus 2 don't give us 0, p of plus or minus 3 don't give 0, and p of plus or minus 6 don't give 0. It is true, you can check it, but just to save ourselves some time here, I'm not going to go through all of those 8 things to be sure that there are no integer factors. Okay, so now we are in the realm of needing to assume a factor of the form ax plus b. Okay, so again let's think about a needs to be a factor of 2 and b needs to be a factor of 6. So a could be plus or minus 1 or plus or minus 2. B can be plus or minus 1, plus minus 2, plus minus 3, or plus minus 6. Okay, so that means that the options for negative b on A are plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 6 over 1, plus or minus 6 over 2. So I'm just putting each of the B options for B together with each of the options for A. Okay. Alright, so let's see what we can rule out. So we've already tested all the integer values theoretically. So 1 over 1 is an integer, 2 over 1 is an integer, 3 over 1 is an integer, 6 over 1 is an integer. So there is actually only 8 options remaining, even though it seemed like there were a lot. Oh no, 6 over 2 is also an integer, because that's 3. So there's actually only, and 2 over 2, sorry, is 4. So there's actually only 4 options here, whilst it seemed like there were more factors, because there's a lot of double up between A and B. A lot of them turn out to be integers when you think about all the divisions that are possible. So we've only got 4 options, so again, we hope it happens early on. Alright, so let's see how we go. Let's try p of a half. So 2 times half cubed is an eighth. So 2 times an eighth is a quarter. Let's see if we can just do that in the one step. Plus, minus half squared, which is also a quarter. And then plus x, which is a half, and minus 6. So obviously they cancel each other out, but these don't cancel each other out. And so this doesn't equal 0. I can't imagine negative half is going to make much difference. So again, the cube term and the x term will change sign. So it'll be negative a quarter, minus a quarter, minus a half, minus 6. So with everything negative, that's definitely not 0. And so actually that probably means it's not going to be negative 3 on 2, because that would make all of the terms negative. So it's probably going to be positive 3 on 2. Let's see how we go. Alright, I might just write out a bit extra here, so because 3 on 2 is a bit more complicated. So we've got 2 times 3 on 2 cubed. 3 cubed is 27 on 2 cubed, which is 8. Minus 3 on 2 squared, so that's 9 on 4, plus x, which is 3 on 2, and minus 6. Alright, 2 cancels down with the 8. Again, don't do 2 times 27. 2 and 8 cancel down to give you 27 on 4. So 27 on 4 minus 9 on 4 plus, let's get a common denominator of 4 while we're here. 3 on 2 is 6 on 4 minus 24 on 4. Let's see where we're at. Let's add together the two positive ones. 27 on 4 plus 6 on 4 is 33 on 4. and then minus 9 on 4 minus 24 on 4 is minus 33 on 4. So that looks good. That is 0, which is good news. And so that tells us that if positive 3 on 2 is a factor, that is because 2x minus 3, if positive 3 on 2 gives us 0, x equals positive 3 on 2 gives us 0, because 2x minus 3 is a factor. Again, you can check it, making that equal to 0, it gives you 2x equals 3, x equals 3 on 2, which is what I want. Okay, so we've identified our factor, we do our long division, sorry, I should have written a bit smaller, dividing that into, what was our polynomial again? 2x cubed minus x squared plus x minus 6, 2x cubed minus x squared plus x minus 6. Okay, what do we multiply? 2x by to get 2x cubed, well that will be x squared times 2x cubed is x squared times 2x minus 3 is 2x cubed minus 3x squared. Subtracting, negative x squared minus 3x squared, so negative x squared plus 3x squared is 2x squared. And we bring down our next term. What do we multiply 2x by to get 2x squared? Well, that will be x. X times 2x minus 3 gives us 2x squared minus 3x. And we subtract, x minus 3x is 4x. And we bring down our next term. What do we multiply 2x by to get 4x? Well, that's 2. 2 times 2x minus 3 is, 4x minus 6, which is good. Confirms that 2x minus 3 is indeed a factor. Okay, so now we know that 2x cubed minus x squared plus x minus 6 equals 2x minus 3 times x squared plus x plus 2. So it's not necessarily the factors might be surds, it's just, in this case, it's that there is only one linear factor, and it's not just x minus a number, plus or minus a number. This second quadratic factor, factors of positive 2 that add up to positive 1, there aren't factors of positive 2 that add to positive 1, so that doesn't factorise any further. You can't factorise that to two linear factors. So the issue here, the reason factor theorem failed us, was that the only linear factor is of this form. Okay, we have a linear and a quadratic factor. Okay, exercise 4D, just questions 16 and 17 cover this idea. Again, it's in the study design. I would hate to not teach it. I've never seen it assessed. I can't imagine that they would do. So I don't want to spend too much time dwelling on this, but I do think you should do a couple for practice.